Hello, Michael. I would like to inform you about some good news. We solved the case! In this video recording, I'll tell you and everyone else watching this in future about the case and the evidence that I have gathered. For now, let's get into exactly what happened on the day of December 16th, 2018. Okay, so let's start from the beginning. We arrive at the crime scene and some observations were made. There were bugs next to the body, tools can be seen, there's a trail of blood, and human footprints, and hair can also be seen. This is everything we've gathered from the crime scene. I'll start off by giving you information about DNA and what it can do to help solve the crime. Now, before we go in depth about this evidence, we need to solve the question, what exactly is DNA? Well, DNA stands for deoxyribonucleic acid and contains genetic information. This genetic information can either link or eliminate a suspect. Now that we discussed what exactly DNA is, let's look at our first piece of evidence. As you know, there are insects next to the body. We can actually learn a lot about what exactly happened that day. What's very important about insects is we can actually find when exactly a crime took place. An important thing we need to discuss is a process of mitosis and meiosis. Cells are the building blocks to every living thing. As you already know, everything must reproduce somehow. Cell division is when cells reproduce by splitting in half. I'm obviously a cartoonist, so I already made a comic about how exactly this works. As you can see here, there are 6 phases. This does explain it pretty well if you're unaware of how this process works. Meiosis is like mitosis, but basically it happens twice. Since we were talking about cell division, we might as well go over sexual and asexual reproduction. I know this topic is a little weird, so I'll try to go over it as fast as possible. Sexual reproduction is when two parents create another organism that is a combination of both parents' genes. Asexual reproduction is like what happens in cell division, where an exact copy of a parent is formed. Now that everything is explained, let's go back to insects. When we analyze what insects are next to the body and understand their life cycles, we get special clues on when exactly it happened. With the information observed, we can determine that the crime happened on December 16th. That's a very important piece of evidence there. We just determined the date of which the incident happened. Here's where things start to get interesting. It's pretty obvious that scientists can track a person down based on their fingerprints. Everyone is unique. Now that that's out of the way, let's talk about our suspects. We've got 6 suspects. I'm going to list them now. Crystal Weaver, Patrick Wright, Tiffany Harrington, Nick Franklin, Natasha Olson, and Malcolm Watts. We have gathered enough evidence to conclude that Suspect 3, Tiffany Harrington's fingerprints, were nowhere to be found, which means we can eliminate her as a potential suspect. That's 1 down, 4 more to go. Like we saw in our observations, there was hair next to the crime scene. We're not exactly sure how it got there, but more evidence for us. Anyway, fibers and hair can lead us to tracking down a person. This can also be effective with clothing as well. The discovery of cross transfers can also dramatically increase the likelihood that 2 people had physical contact. Genetics is also a big part in this. Heredity is the term used for traits you get from your parents when you were born. Like brown hair, for example. Everything about you is determined by genetics in terms of traits. There's both dominant traits and recessive traits. Knowing this, we should probably get into Punnett squares. Punnett squares help us visualize exactly how genetics work on a much more watered down example. Basically, you have 4 squares. 2 letters on the side and 2 on the top represent your traits. For example, let's say that uppercase B stands for brown hair and lowercase b stands for blonde hair. The uppercase letter is known as the dominant trait, which means it always goes first in the Punnett square. The lowercase letter is the recessive trait, which means it goes behind in the Punnett square. If any combination has an uppercase B, that means that the person will have brown hair. If there is no dominant trait, only lowercase levels, that means the person will have blonde hair. If you take the squares together and come up with percentages using your phenotypes. Now that that's explained, let's go back to our suspects. We have 5 left. After investigation and hairs collected from the suspects, we compare them to the hair found at the crime scene. We found out the hairs do not seem to match either Natasha Olson or Malcolm Watts. Using that information, we can eliminate both of them for being potential murderers. Before we talk about other pieces of physical evidence, let's bring up interrogations. We interrogated each and every suspect and found where they said they were. Patrick Wright said that he was out of town and flew to New York. A visa receipt confirmed that he bought those plane tickets and thus was not in town during the crime. We can now eliminate him as a potential suspect because he was not in the area at the time. We can find traits in families with not just Punnett squares, but with pedigrees as well. These show the occurrence of traits passed from generation to generation. Circles show females and squares show males. A solid shape shows that a person has that trait, and a half shape shows that the person does not have that trait, but carries it. Think of it as dominant traits and recessive traits. The dominant is when they do not have it, and the recessive is when they do. Alright, let's look at the body. The entire skeleton, from head to toe, is 5'3". This can't really be used to find age, because it can either be an adult or a young adult. There is no real way of knowing. But if we look at the back of the skull, we can see a large wound in the back. This could be a gunshot wound, but the scratches around the skull tell us that it was not a gunshot wound. But the victim was killed with a pair of scissors. Scissors? Really? Oh man, that's the worst way to go. Let's just move on. Impressions are evidence defined as tools or used as other materials that have a direct contact with the body. In this case, our evidence here is that the scissors was used as the weapon. Now, we're finally down to two suspects, Crystal Weaver and Nick Franklin. Both people could not get anyone to confirm their alibis. Crystal suffers from superfemale syndrome, and Nick suffers from Superman syndrome. Blood samples can be used to link a person to the crime. Drops and splatters can lead to clues explaining how it happened. We've taken a blood sample taken from the murder weapon. After constructing a karyotype, we found out the killer really is Nick Franklin. The blood shows that the killer had Superman syndrome, meaning it matches perfectly with Nick. Well, we did it. We found out who the killer is. First, we looked at the insects to determine what happened. Then we looked at fingerprints to eliminate a suspect. Then we saw that Patrick was not in town. Hair samples show that two people definitely weren't there. Figured out the murder weapon was scissors, and then came to the conclusion that Nick Franklin was the murderer. To conclude, we found out that Nick Franklin was the murderer. Clear evidence is here to support that, as you can see with the observations and the signs that I said before in this video. I believe this is a very clear answer. Thank you so much for following along and listening to what I have to say about this horrible crime. Now you can make Nick Franklin pay for what he has done. Goodbye, Michael.